Hello friends, in this video we will discuss about a very important curve, cycloid. Cycloid. It has very much engineering applications and generally people find difficulty in drawing cycloid and understanding about its method and plotting. So look carefully. We will discuss about cycloid. I am writing the name here. Cycloid. This is very important curve. All about it. So let's start. First, let us know what is cycloid. Cycloid is a curve or locus of a point, suppose A, isn't it? On the circumference of a circle, which is made when circle rolls without slipping along a straight line. Understood? Again I am repeating. Cycloid is the locus of a point A on the circumference of a circle traced when circle is rolling without slipping along a straight line. Just I am trying to demonstrate it crudely, in a crude way. Look, suppose this is a round object, circle it is. I put one dot here, you could see red dot. Okay, now this is a straight line. Okay, now I will roll the circle without slipping, means like this, not, it should continuously roll, point to point contact. Okay, so now look this point, how it travels, how the locus is found. So look, here is the dot, it is on the foot now, or who cannot see the dot, so just imagine here is a point on the foot. Now how foot goes, isn't it? Here is a dot I made, so try to look that. So I am rolling it now, so look how this dot goes. Look, it is going like this, like this, like this. Here it is now. Now it will come like this, just like a very shallow parabola or hyperbola, like that, more or less. Look, so again I am doing, this is the point I made here. Look, it starts from here, and after making a complete turn, this will come again here. Look, so how it is going. Look, here it is, like, look, you can see like this. So it goes like this, isn't it? So this locus is called cycloid. There are some more types of cycloid, epicycloid and hypocycloid. When circle rolls along a big circle or inside a circle, so outside the circle if it rolls, so that locus is obtained, that is called epicycloid, and inside it rolls, so the locus obtained is called hypocycloid. So that combination is used in gear manufacturing, actually soundless gear manufacturing, in watches generally. Cycloid teeth profiles are there. Whereas one more type of tooth profile is very common, that is involute tooth profile. That is in almost outside you can see, just in sugarcane juice maker, that machine. In that also two wheels are there, so their teeth are having the curve, that is involute tooth profiles. So they hammer each other, they shift, making noise and digging each other. Life is somewhat less, but in watch mechanism there is no sound comes, just leaving that tick tick sound. There is no any sound, it's totally soundless. So very smooth that operation happens. That we will discuss one by one when I will take involute or epicycloid, hypocycloid. Just now I am taking cycloid. Just this for your general knowledge, I covered these points for Viva-Voce. So I am making now cycloid, and I will tell you how to draw. So first I will make straight line. This is straight line, and sorry, some tilted it is. Okay, so suppose here is the starting point. So circle I am making. So this is starting point of circle. This point is A. Now, after making complete turn, this is the last point. This is the last situation. So this A and A will again come here. So the locus of A throughout its journey, when circle was, this may be a disc, circle was rolling without slipping point to point along a straight line. So like this would be its highest point, and then it is means apogee, and like this it will be made. That we will try to make. We will now discuss how to make. So as in circular plotting, like in ellipse also. So we will divide this circle into equal number of parts. Let it be 12. Okay, now okay. In 2 steps only these graduations are made, and we could name them. This is A, so this is suppose 0, this is 1, this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and this is 12 also, 0 or 12, and this is our point under consideration A. We will make the locus of A. Now look, when it will roll and reach here, so on the straight line it will travel the distance equal to 2 pi r, where r is the radius. R is the radius of the circle, so this will be 2 pi r. Okay, so this circle is divided into 12 parts, 12 equal parts. So this 2 pi r, so this is that 2 pi r length. So corresponding points we will make here. 1, so 1 dash on this. 2, so when it will roll, so 2 will fall on 2 dash. So those will be equal to 0, 1, 1, 2, 2, 3, isn't it? So we will have to divide this line into 12 equal parts. So each part will be equal to the length of the arc 0, 1, 1, 2, like that, isn't it? So sector of the arc. So let's divide into 12 equal parts. So some more here. Okay. Now it is half, and 6 parts, and this 6 parts. 1, 2, like that. 3, 4, 1, 2, 3, 4, 5, 6, 7. Oh. So increasing M. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, somewhat less. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11 and 12. Okay, now next step is to make verticals from, now let's name them. One will fall on 1 dash, 2 will fall on 2 dash when circle will roll. Then 3 will fall on 3 dash. Then 4 will fall on 4 dash. Then 5 dash, 6 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, and this is 12 dash. And A will come again. Okay. Now we will have to draw verticals through 1 dash, 2 dash, 3 dash. Okay. So I'm in dotted I will make. However, on sheet you have to make by 4H lines. This up to here. And this line also we will proceed. All centers will be on this line. Okay. Now from 2 dash, this will be so this will be 1 through this is C. Now through when 1 will fall on 1 dash, so foot will be 1 instead of A. A is on the circle. Now A will reach here and 1 will fall on 1 dash. So circle will be here and corresponding center will be here, C1. Similarly, when 2 will fall on 2 dash, so foot will be on 2 dash and corresponding center will be C2. Similarly, here when 3 will fall on 3 dash on while rolling, this new center will be at C3. Similarly, C4, C5, and this is last, and this is C12. Okay, that would be last position. So here C4, here C5, all verticals, C6, C7, C8, C9, C10, C11, and this is C12. So it is quite obvious that, okay, now we will have to draw lines, horizontal lines passing through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. To know the levels, when 1 will fall on 1 dash, so A will reach at how much horizon? The same horizon, isn't it? So look, horizontal from 1 will pass through 11 also. 2 and 10 both will be on the same line. Similarly, 3 and 9 already same line. 4 and 8 on the same horizon. 5 and 7 will be on the same horizon, and 6 separately. So this 1, 11 and 1, isn't it? Similarly, 10 and 2, isn't it? And this is 3 and 9 already line is there. So this line and 4 and 8 okay, then 7 and 5 and this is from 6. Okay. Okay. This will be 6 dash. Okay. So now we know that when one will fall on, this one will fall on 1 dash, then A will rise to the same horizon. One got down from 1 to this 1 dash, means this much it got down. So A, which was 0 or 12, will rise to the same horizon, means A will be on the line joining 1 and 11. Means similarly, just think one by one. When 1 will fall on 1 dash, then A will be on the line from 1. When 2 will fall on 2 dash on rolling, then A will reach on the horizon from 2. Similarly, when 3 will fall on 3 dash, then A will reach on this line. When 4 will fall on 4 dash, then A will reach on this line through 4. And when 5 will fall on 5 dash, then A will reach on line through 5, means on this line. And when 6 will fall on 6 dash on rolling, then A will reach on this line. Similarly, and after that, when 7 will fall on, look, it is going down. 7 will fall on 7 dash, then A will got down to the line through 7, or it is the same line through 5, isn't it? And again, further, when 8 will fall on 8 dash, then A will reach on the line through 8 or 4, both will be same, isn't it? So like this. So we know on which horizon or on which line A will be. And what will be the centers? When 1 will fall on 1 dash, the center will be C1. When 2 will fall on 2 dash, then center will be, new center will be C2, isn't it? When 3 will fall on 3 dash, then new center will be C3, isn't it? And foot will be 3 dash. And so on. So we know where the center will be. Its center will be where the circle will be, isn't it? The new position of circle will be where, that we know. When 1 will fall on 1 dash, then A will be on the line through 1, that we know, and circle center will be at C1. And so the distance of A will always be from its center how much? R, equal to radius of the circle. So this is the new center, and A will fall on this line. So how we will locate the position of A? We know that A will be on this line, but where? So center of the circle will be this, and the distance of A will be from circle center how much? R. So we will take center C1 and make an arc equal to R, small r, isn't it? That we made 2 pi r, isn't it? So we will take an arc of R and arc of radius R, and taking center as C1, we will cut here. So it will cut here somewhere. Similarly, when 2 will fall on 2 dash, so we will take arc of radius R, taking center as C2, and we will cut line through 2. Suppose line through 2, isn't it? So C2 is center and line through 2 is this. So here somewhere it will cut, and similarly from C3 we will cut on this line. It will, this is C3, and it will cut somewhat somewhere here. Then from C4 we will cut, means once we took the arc, we took rounder and separated the legs by the distance of radius R, and then we are cutting. So taking this center on this, taking this center, suppose it will cut here. Taking this center, it will cut suppose here, and taking this center, it will just tangentially cut, and then it will start coming down. 8, it will cut here, C9, so it will cut here somewhere, C10, so it will cut somewhere here, center will be here, and it will cut somewhere here, C11, this will be the center of the circle, and it will cut somewhere here, and C12, so it is the last position, isn't it? From here you will cut, so here only it will cut, isn't it? So here it cut, here it will cut, here it will cut. Okay, so like this the locus will be made, isn't it? So I'm traversing this is the cycloid. This is the cycloid. So understood. Now I will tell you one more thing, how to draw tangent and normals at any point to the cycloid. Suppose position is given. In the question, position is given for the point that after this much angle. So corresponding point we will find here. So suppose after 60 degree. So 30, these all are 30, 30, 30, 60. So corresponding point on the cycloid we have to find out first. So this time 2 2 will fall on 2 dash. So 2 will fall on 2 dash. So where will be its center? Here. And corresponding point will be here. So here somewhere. So C2 radius, C2 center and this arc radius. So suppose here. So we have to make tangent and normal at point this, isn't it? So what is the principle that you listen carefully? If we will join the current foot to the point, then it will be normal. So look, this 2 dash will be joined to this. This will be normal. It will always be at normal. And tangent will be 90 angle to this. This will be tangent and this will be normal. Similarly, suppose our point falls here. At any center we could do, isn't it? Means distance will be given after this much distance. Suppose after 17 mm or after 51 mm. So suppose this 51 mm. So corresponding point by taking perpendicular distance, perpendicular line. So here suppose. So what we have to do, its current foot we have to find out. So we will take we will make this center and we will take arc on means we will have to do just opposite thing. How this point was made to the center, to the center line where new center was there, we took it as a center and our arc we took to the corresponding horizontal line where A could be. But here we know A is here. A is here. And now making A as center, we will take radius R and cut at the center lines. So suppose here it cuts. So this would be the foot. Sorry, this would be the new center. This is current C. So C asterisk I am putting, and corresponding foot will be got by drawing perpendicular. So this will be corresponding foot. Now, so for foot F I am writing. Now this foot is to be joined to the point on the current situation of that cycloid. Foot should be joined to the current position of the point, or point is to be under consideration is to be joined to the current foot. So this is to be joined. So this is normal end, and tangent will be 90 degree to this. This will be tangent. Okay. So this is all about cycloid, and as I told you, there are two more types of cycloids, epicycloid and hypercycloid. That I will make another video for that, and we will discuss there. So that's all for this video. Thank you.